All right, so we're back again for part 4. We just finished this slide and answered this question about how to solve density problems. So I hope that you have a really good idea of how to solve density problems. Here we're going to talk about some physical properties. Malleability is a big one. Here's one that's coming back from properties of matter. It's the ability to be pounded into thin sheets. For example, aluminum can be rolled and pounded into sheets to make foil. In fact, back in the Middle Ages, they used to take gold and pound it into tiny, tiny thin sheets and actually put it in sacred books like the Bible, to put gold gilding in the Bible and gold leaf in the Bible. Ductility is another physical property. It's the ability to be drawn or pulled into a wire. Example, copper wire being soldered into wire, or joints, anything that's made into a wire. It's an actual physical property of metals. Another physical property that we've talked about a little bit, and we'll get into maybe to more very soon, is solubility. That's the ability to dissolve in another substance. For example, sugar or salt to dissolve into water. I want you to think for a second a lab that you just did where you talked about the solubility of something. And if you're thinking your M&M lab, you're absolutely correct. And you probably have already guessed this, but 3 ways to increase solubility are heat to make it warmer. So the warmer water in the M&M lab dissolved faster. Grinding it or smashing it, we didn't get to play with that. Or stirring and mixing is another way to increase solubility in a substance. You probably noticed that you had to do that when you made your sugar waters. Another huge physical property would be states of matter, our solid, liquid, gas. So in a solid, matter has a definite shape and volume, and we'll talk more about this later, what that means. Liquid is matter that takes the shape of its container and has a definite volume. And gas, the matter changes in both shape and volume. Another physical property that we can talk about is thermal conductivity, the ability to transfer thermal energy, basically heat, from one area to another. For example, plastic foam of your cheap plastic foam cups is a poor conductor, so a hot drink won't burn your hands, whereas metal is a fantastic conductor if you've ever accidentally touched a hot handle. There's another bad conductor. Some glass is a bad conductor, and it will, like Pyrex especially, you like heat that stuff up. In a microwave, it's not so bad. In an oven, you're probably going to want to grab some mitts. So if we have physical properties, we have chemical properties. And some of the chemical properties that we're going to want to talk about first, let's get ourselves a definition. A property of matter that describes a substance based on its ability to change into a new substance with different properties. And that's really the key in anything chemical changes, is that it has different properties. It changed into something new. So if we have combustibility, flammability, reactivities. Is it an acid? Is it a base? Is it an oxidizer? Some other things about chemical properties. They're really hard to observe with your senses, whereas things as like if something's ductile or malleable, or even if it's dense or not dense, can be observed with your senses. Flammability, only when the wood burns. Combustibility is only when the fireworks explode. I mean, you could have these fireworks sitting there and the chemical property is sitting right in front of you, but it's completely stable until you light that fuse. And then reactivity, only when the iron oxidizes, that is, has rust available into it. So now we're going to talk about, so now what I want you to do is, we've got chemical and physical properties. Let's just keep going on. And then we have chemical and physical changes. So Physical change is that it affects one or more physical properties of a substance, but it does not form new substances. I cannot emphasize that enough. It does not form new substances. Most often it can be redone. For example, butter on the counter can be placed back in the refrigerator. Changes of state, we see this all the time with water. You can have on any given day, you could have snow in the morning that melts into liquid water that evaporates by the late afternoon. And so that's the idea of a chemical change. 5 signs of a chemical change. The only sure way to know there's been a chemical change is the observance of a new substance formed. And so sometimes that's really hard to do. So scientists look for basically a couple of things. We look for an odor production. Remember, we're always wafting. Let's do the wafting. This is an odor far different from what it should smell like in everyday life. This would be rotting eggs, food in the fridge that's gone bad, decomposing flesh. Most of us knows the very peculiar smell of that. That's a chemical change. A second sign of a chemical change is a change in temperature. So this is where we have we have 2 changes in temperature. The temperature can go up or the temperature can go down. If you observe a temperature going up, that's exothermic. Why is this all black? It's really unhelpful. That's exothermic. That's change going up. And then you have endothermic, and that's the temperature actually going down. Okay. And ironically, when you have the exothermic reaction, what you're doing is that you're releasing energy into the environment. You're releasing energy into the environment. Sorry, I'm trying to find a pen I can use. You're releasing energy into the environment. You're releasing energy into the environment. And so then because the energy is released, the energy is lessened from the system, that's why you feel the temperature change. Ironically, the one I think that's harder to understand is that when energy is absorbed, we see this temperature change go down. You feel cold. And we'll play with this later, where we'll play with some endothermic and exothermic reactions. And endothermic are always my favorite over exothermic because they're just so much more fun. It got cold. Changing color. Okay. Fruit changing color when it ripens. Autumn leaves changing color in the autumn. Dyeing your hair. Those are all chemical changes. You did a color change challenge. That was chemical changes. Formation of bubbles. Yay, bubbles. This can indicate the presence of a gas. Bubbles produced when boiling water is not a chemical change. So you got to watch it. Bubbles doesn't always mean a chemical change, but if it's just sitting there, it's not being heated up, and you've added 2 things together, then you definitely have a chemical change. So this might be some little bit of elephant toothpaste like thing going on. Alka-Seltzer, I don't know if you guys know the thing, pop, pop, fizz, fizz, oh, what a relief it is. And I don't know what that third one is, but bubbles. And the 5th sign is the formation of a precipitate. So I'll say that again, precipitate. So we'll play with these later. I will definitely find a reaction when we form precipitate, because that's, again, one of my favorite things. And that's when 2 liquids are combined and a solid is produced. look on the page for what I expect in terms of assignment for this. And thank you so much for watching all of these. Thank you.